welcome to my channel. In this video, let me discuss about mathematical logic. Generally, logic provides certain rules. One can determine whether the given argument is a valid one or not a valid one. So, a logic is a set of reasoning, whether they are legal arguments or mathematical proofs or conclusions on a scientific theory based upon a set of hypotheses. Any collection of rules or theory needs some language in which they are stated. The formal language is one called the object language. So, a formal language is in which the syntax is well defined, isn't it? The difference between the logic and other disciplines is in other disciplines, that is, we are concerned with the use of object language. In logic, we are analyzing the object language. That is, we are using symbols in logic. It's a very important thing you should know. Therefore, logic is also called symbolic logic. We are using English as an object language. It is also called the meta language. Now, let me see what are the statements and notations. The simple sentences are called statements. That is, the simple sentences are also called primary or atomic statements. The statements are denoted by capital letters like P, Q, R, like that. In object language, we are giving two possible values called truth values. Okay, they are denoted by either T or F, which means true or false. T means true, false means F. So, the two primary statements are connected by some connectives are called molecular statements or compound statements. Now, let me see what are connectives. In English, we using the words but, or, and between two simple sentences are called connectives. Negation. Here, the negation of a statement is obtained by introducing the word not at the proper place of the statement or prefixing the phrase, it is not the case that, in this statement. Suppose, if P is a statement, then the negation of P is denoted by this, like this, that is negation of P, which means not P. Let me show you the truth table for P. Here we have only one variable. So, for the one variable P, we have two possibilities. Either it may be true or false. If it is true, its negation is not true, which means false. If it is false, its negation is true. That is opposite. If it is true means false, false means true. For example, let me give you an example for your understanding purpose in a sentence like this. Suppose let me take P. Here the statement represent P is nothing but Chennai is a city. I am going to write the negation of P in either of the two ways. Either I can say negation of P as Chennai is not a city, or I have to say negation of P as it is not the case that the Chennai is a city. Both are the negation of P. As another example, let me take the statement P as I went to the class yesterday. Here I am going to give the negation of P in either of the three ways, either the first, second or third one. So that is the first one as I didn't go to the class yesterday. That is negation of P, isn't it? Or it is not the case that I went to the class yesterday. That is also negation of P. That is not P. Or the other way, I was absent to the class yesterday. So these three ways we have to give the negation of the statement P. Next, what is the meaning of conjunction? That is what we are going to see now. The conjunction of two statements P and Q is the statements P and Q is read as P and Q. Here P and Q, which we have to read as P and Q. The truth value for P and Q is true when both P and Q has the truth values T, otherwise it has a truth value false. Let me show you the truth table for P and Q. Here there are two variables. In your previous, here two variables, so totally we have 2 square. General formula is 2 power n. So 2 variable means n is 2, 2 square means 4. So totally we have 4 possibilities like that. 1, 2, 3, 4. True, 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 false, false, true and false, false. Now let me have look at what is the P and Q truth values. That is true and true, true. Here true and false, false. False, true, false. False and false, false. So this has only true when both the variables P and Q is true. Okay. Next. For example, let me show you a statement for your understanding. Jack and Jill are cousins. Here, and is not a conjunction. Why? Note that the truth values for P and Q and P are equal, then only and is taken to be a conjunction, or otherwise you can't take and as a conjunction. Okay. Next, we move on to disjunction. The disjunction of two statements P and Q is the statement P or Q, okay, which means P or Q, the truth values for P or Q is false only when both P and Q has the truth values false, otherwise it has a truth value T. That is true. Let me show you the truth table for P or Q. So here itself two variables, so totally we have 2 square means 4 set of possibilities like this, truth values. So it has truth value false only when P and Q both of them has the truth value false, or else otherwise all of them has the truth value. To look at here, true or true, that is true. True or false, true. False or true, true. False or false only we have false. Okay. Next, let me give you a statement for your clear understanding of the distinction. I shall watch the game on television or go to the game. Here, or is used as an exclusive sense. That is, one or the other possibility exists but not both. Isn't it? I think you understand the meaning of or now. Let me give you another example. There is something wrong in the bulb or wiring. Okay. Here itself or is used in an exclusive sense. That is, one or the other or both possibilities exist. Okay. Next, 20 or 30 students in the class. Here, or indicates an approximate number but not a connective. Okay. Now, let me move on to what is the meaning of statement formulas. A statement formula is an expression which is a string consists of variables in terms of capital letters, parentheses and connectives like and or negations, okay, something like that. Now, the statement formulas formed by P and Q, formed by the two variables P and Q are either negation P, P or Q, P and Q, negation of P and Q. Here, the variables in the statements are called components. Okay, let me show you the truth table for this. Construct a truth table for P or negation Q. So here you have two variables. If it is two variables means totally we have 2 square, that is 4 set of possibilities like this. True, 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 false, false, true, false, false. Next, negation of Q. So we have to find the truth table for P or negation Q. First let me find what is negation of Q. Negation of Q is nothing but not Q. If it is true means you can write false. False means write true. That is contrary. That is true means false. False means true. So now we have negation Q. Now we can use the disjunction between P and negation Q. That is P or negation Q. So true or false, true. True or true, that is also true. False or false, that is only false. Okay, false or true gives you true. Okay, so we can use of the another method too. That will seems to be something tedious, so I just omit these method and follow this method for your clear understanding in the forthcoming examples. Okay, consider the truth table for P or negation P and negation P. So we have only one variable P, so we have only two possibilities. 2 power 1 means 2, that is only true or false is only two values. Okay, that is the two truth values for the variable P. So negation P is nothing but if it is true, you have false. If it is false means true. Negation P is nothing but true, isn't it? So now what we are going to find P or negation P. Okay, so P or negation P. So you have to take or, disjunction, true or false, that is true, false or true, true itself. Okay, so the negation P, that is the disjunction, takes the value false whenever both the variables takes the value false, otherwise it takes the value true only. Okay, isn't it? Next we move on to P and negation P. Okay, that is and symbol. Now true and, now instead of taking disjunction we have to take conjunction here, that is and. True and false, that is false. False and true, false, because in conjunction whenever the both variables take the values true, then only we have the truth value true, or otherwise we have the truth value false only. Next we have to move on to construct the truth value for P or Q or negation P. Now here we have two variables, so we have totally four possibilities, that is four set of truth values, that is true, 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 false, false, true and false, false. Now first let me first find negation P. So negation of P is nothing but if it is true you have false, if it is true here false, that is false means negation P is true and false means negation P true. Next we have to find second one, P or Q. Next we have to find P or Q. That is we have to take disjunction between P and Q. So true or true is nothing but true. True or false, true. False or true, true. And false or false, that only false alone. Okay. Now what is going to do next? We have to take this disjunction between these two. Okay, that is the last column. Now let me combine these two by disjunction, that is false or true, that is true, false or true, true, true or true, that is true, true or false, true. So finally we get the truth table values of all these is nothing but true only. Now next one, construct the truth table for the following. So here I have to take nearby 6 problems, so we have to discuss one by one in detail. So first one is negation of negation P or negation Q. Look at here. First look at the variables. Here we have two variables, so 2 square means we have 4 set of possibilities. So in a table in the first two column you just write out P and Q. What we are going to do next is you just first find negation P. Okay, so negation P is nothing but if it is negation of P is true means false, true means false, false means true, false means true. So after finding negation of P, next one is calculate negation Q. So next calculate negation Q. In Q we have first one, false means false, sorry, true means false, false means true, true means false and false means true, that is the opposite. After that you have to take the distinction between these two, or. So negation P or negation Q, that is false or false, false, false or true, true, true or false, true, true or true, true. Finally you have to take the negation of these. Okay, that is you have to take the negation of these, negation P or negation Q. So false negation means true, negation of true, that is true means false, true, false, true, false, we take just negation, that's all. So this is the truth table for negation of negation P or negation Q. The next one is, let us find the negation of negation P and negation Q. Only the difference between previous and this one is there we have used disjunction, here we move on to conjunction, that is and. Okay, so as usual here two variables means we have 4 set of possibilities, That is true, 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 false, false, true and false, false. First you have to find negation P. So negation P is nothing but true means false, true means false, false means true, false means true. So after finding the negation P, next you find negation Q. So negation Q, true means false, false means true, true means false and false means true. Next you have to take the conjunction between these two, that is and. So negation P and negation Q. So false and false, false. False and true, false. True and false, false. True and true, that is only true. Okay. Finally you have to take the negation of this. Okay, so if you take the negation of this means false, that is negation of this one is true. That is false means true, false means true and true means false. That is a negation, isn't it? That's all. Let me move on to next one. So it consists of a lengthy statement like this. That is negation P, and it consists of both the disjunction, that is and or. Disjunction and conjunction, and also the negation of the variables too. Now you have three variables here. Look at here that we have three variables P, Q and R. Since we are having three variables means, as I told you already, if it is three variables means 2 power 3. So totally we have 8 possibilities. Okay. So totally we have 8. So these are all the 8 possibilities. So now first one, true, 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 false, true, false, true, false, true, true. Next you have to replace one of the variable as false, next by 2. True, false, 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 true, and false, true, false, next false, false, false. That's all. Now what we are going to do is, we have to simplify this. For that what we are going to do is, first we have to find negation P. Okay, this one, and negation Q, this one. What we are going to do, first we have to evaluate this one. Okay, so for that first we have to find out, this is what your first operation you are going to carry out, that is negation Q and negation R you have to calculate. So after that you go with negation P and operator. Okay, so you have this one, so you have to take and operator between negation P and this one. Okay, next Q and R, next P and R, these are simple. So next you have to combine these three and you have this truth table like this. Okay, so the concept being simple, only the number of variables being 3, and so that you have the truth values for these 3 variables 8. Okay, that is the only difference. Okay, so here in the last column you get the values like this. Okay, so since I didn't have space, so that I have to write down the last column value. So this is your answer. Okay, now the next one is P and PRQ. This is very simple one, isn't it? Here we have 2 variables PQ. So 2 variables means we have 4 possibilities: true, 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 false, false, true, false, false. So we have to use disjunction between these two. That is true or true, true, true or false, true, false or true, true, and false or false is alone false. So you have to take conjunction, that is and operator with P. So for that you have to combine this with this one. So if you apply AND operator means what happens? True and true. This one, true and true. That is true, true and true, true, false and true, false, false and false, false. The last one, P and Q and P. Here we have to use only the conjunction and. So you have here the 2 variables, so we have 4 possibilities like this. So first you have to take Q and P. Q and P means you have to first look at Q and then P. So true and true, that is true, false and true, false, true and false, false, false and false, false. So in the AND operator, which one you have to take first or next gives you the same set of truth values. So whatever that may be, so if you have to follow the process, because in conditional statement that will be different. Okay, so that's why I have to take what is given in the order we have to follow. Right, now next you have to take the conjunction of this one with P. So P and Q and P. So here you have true and true. So you have true, true and false, false, false and false, false, false and false, false. So the next one also the lengthiest one, So here you have P and Q or negation P and Q, or P and negation Q, or negation P and negation Q. But the statement seems to be lengthy, but we have only two variables, so we have four possibilities. So here you have first find negation P, negation Q. So first find out P and Q here. Next negation P and Q. Okay, this one. Next P and negation Q you have to calculate. Next negation P and negation Q you have to calculate. Next, what you are going to do, you can't combine all these simultaneously. For that, what you are going to do is, you have to combine these two first. Which means, you have to combine the truth values of P and Q with, that is, disjunction, or with negation P and Q. That is, you have to combine these two by disjunction. And also P and negation Q with negation P or Q. So that we have these two columns. So finally you have to make the disjunction, that is or, that is true or false. Okay, this is the final answer. True or false is nothing but false. That is, in the final column is shown here. So, sorry, true or false. So we have disjunction. So we have, finally we have all the truth values for this one is true itself. Okay, that's all. Next. Now, let me give you some example. Instead of using truth table, the values of P and Q as given as true or false, and let me find what is the resulting truth value of these statements. Given the truth values of P and Q as true, so you have to take the truth values of P and Q as true, and those of R and S as false. So R and S, where is S? Here you have. So R and S as false. Find the truth values of the followings. So let me first work out. There are three examples. Let me first work out the first one. If it is, that is given that P and Q alone takes the value true, and R and S takes the truth value false. So P, R, Q and R. That is, P takes the value true, Q takes the value true, whereas R takes the value false. So first, let me first work out the conjunction. That is, true and false means in conjunction that is false, isn't it? So we have true or false, whereas in disjunction, if any one of the values becomes true means we have true. So true or false means true. That is the answer. Coming to the second one. The second one is P and Q and R. This is the second one. R, negation of P, R, Q and R or S. So here I am just write down the results directly. So for P you have true, and Q also you have true, R you have false, where R negation of, here true or true and false or false. Okay. Now, let me first work out the values within the parenthesis first. Okay. First give the importance for the parenthesis, inner parenthesis, and we move on to outer parenthesis. So, true and, first we have true and false is false. So, this one over. Or negation of true or true is true itself, and false or false is false. That's all. So here true and false is false, isn't it? Or negation of true and false is false. Negation of false is nothing but true itself. False or true is true. That's all. So next one. Last one also, I am just write down the truth values directly. So finally you get the truth value as true alone. Next we move on to very important concept, that is a conditional statement. Okay. So, if P and Q are two statements, then the statement P conditional Q, you have to read this one as P conditional Q, which means if P then Q, is called the conditional statement. Here, the statement P conditional Q has the truth values false if Q has the truth value false and P has the truth value true, otherwise it is true. Okay, let me show you the truth table. For that you can get a clear idea. Here P is called the antecedent and Q is called the consequent. So let me show you the truth table for P conditional Q. So here we have two variables, so totally we have possibilities, totally four possibilities are there. So P conditional Q is false only when P takes the value true and Q takes the value false. Otherwise all the truth values are true only. Okay. So the remaining are we have only two. So only this false exists only when the P has the truth value true and Q has the truth value false. Okay. Next, let me show you a statement which gives you a clear insight about the conditional statement. Example, express in English the statement P conditional Q, where here the statement P represents the sun is shining today and Q represents 2 plus 7 is greater than 4. The solution, suppose if you are going to express this in terms of P conditional Q in form as if P then Q. The P conditional Q means if P, this is P, isn't it? If P then Q. Okay. So here if P is the sun is shining today, then 2 plus 7 is greater than 4. Now you got the conditional statement. What is conditional statement in brief? Write the following statement in symbolic form. If either Jerry takes calculus or Ken takes sociology, then Larry will take English. Here I have to represent these three statements as P, Q, R. That is, P represents Jerry takes calculus, whereas Q represents Ken takes sociology, and R represents Larry takes English. So the symbolic form is either Jerry takes calculus or Ken takes sociology. So P or Q. Then, so that conditional, Larry will take English. So R. So P or Q, conditional R. This is the symbolic form, isn't it? The next one, write in symbolic form the statement, the crop will be destroyed if there is a flood. Here itself the statement is represented as, that is P and Q, as the crops will be destroyed as P and there is a flood as Q. Here the symbolic form is Q conditional P, isn't it? If there is a flood, then the crops will be destroyed. So that Q conditional P, not P conditional Q. Okay, got the point? Right. Now let me construct the truth table for P conditional Q and Q conditional P. So here we have two variables, so that totally we have 2 square means 4 possibilities, that is 4 possible set of truth values, true, false, false, true, false, false. So P conditional Q takes a value false only when value P takes true and Q takes, that is a variable Q takes false. So otherwise all the remaining truth values are true only. Next, Q conditional P means the same concept. Whenever the value of Q, that is a variable, takes a value true, that is Q takes true and P takes false, this only, when in this case only Q conditional P takes the value false, all the other cases are true only. Now you got the difference between P conditional Q and Q conditional P, isn't it? So if P is true and Q is false, then only P conditional Q means false. Q is true and P is false, then Q conditional P means you get the value false, truth value, right? That is the only difference. All the remaining possibilities, that is in all remaining cases, are true only. Now we have to take the conjunction between these two, that is P conditional Q and Q conditional P. If you apply AND operator between these two, true and true, true, false and true, false, true and false, false, true and true, true. So the next one, construct the truth table for Q and P conditional Q, conditional P. So here we have to apply two conditional. Okay, now what we are going to do is, first let me write down the truth values of P, Q. Here we have two variables, so totally we have 4 possibilities like this. So P conditional Q takes a value false only when P takes a value P, true and Q takes a value false, and Q and P conditional Q. So true and true, that is you have to combine these two using conjunction. So true and true, true, false and false, false, true and true, true, false and true, false. Next we have to apply the conditional operator between these two, that is Q and P conditional Q, conditional P. So this takes a false value only when Q and P conditional Q having the truth value T and P has a truth value false. That exists only for the third case alone. So true false means here itself false, all the other cases having the truth value true. So look at this is your first thing you have to look at here, and this is what the second one. So look at here, there are two true values. Okay, so here corresponding to these two are here for the first one we have true, second one we have false. So for this possibility only we have false, and the remaining all the remaining are true only. Okay, next biconditional statement is a very important thing you should know. So if P and Q are the two statements, then the statement B biconditional Q, which is read as a P if and only if Q or P double F, I double F, okay, in short form. P if and only if Q. Here the statement P biconditional Q has the truth value true when both P and Q has identical truth values. Let me show you the truth value. That is a truth table for your clear understanding. So if both of them have the identical truth values, it has the truth value true, which means if it is true means both of them true. If it is false means both of them false. Look at here. Here both of them are false, so that it has the truth value true. Here both of the statements P and Q has the truth value true, so same truth value. Now here there are opposite, true false, so false, false true, false. So if it has different truth values means you get false, and if it is identical you have the truth value T, that is true. Now construct the truth table for negation of P and Q by conditional negation P or negation Q. Here we have two variables, so two variables means totally we have four possible set of truth values like this. Now first let me find out negation P and negation Q. Okay, so negation P is nothing but negation of P, that is if it is true means false, next true means false, false means true, and false means true. Next like that we have to find negation Q. Okay, true, false, false means true, true means false, false means true. So after that we have to find P and Q. So P and Q means we have to combine P and Q using conjunction, that is true and true, that is true. True and false, false, false and true, false, false and false, false. Next you have to take the negation of this. So negation of this means true means false, false means true, false means true, false means true. So the negation of this one. Okay. Next negation P or negation Q. You have to apply OR operator between these two, right? False or false, false. False or true, true. True or false, true. True or true, true. Next what you are going to do is, so this we have find the negation of P and Q, also negation P or negation Q, these two. So let me apply the biconditional statement between these two, that is negation of P and Q, biconditional, negation P, negation Q. As I told you already, so whenever both of the truth values are identical, it has a truth value T. Here a false, false. Both of them having the same truth value, so you get true here. So here true, true, same truth value, true. True, true, same truth value, true, true, true itself. So finally we get only true values. Construct the truth value for here. We have three variables P, Q, R. So totally we have Q cube, that means 8 possibilities. So let me explain this in short to you. So first what you are going to do, find is you just find out the inner parenthesis values first, that is Q and R calculate. Next you have to take the disjunction between Q and R with P, so this one, and you have to take the negation. Okay, so negation. So we have to find this left hand side value, that is the first one. Okay, this one over. Let me come to the right hand side. So on the right hand side we first calculate P R Q and then P R R. Next we have to apply the conjunction between these two. So if you apply the conjunction between these two, you get this one. So what we are going to do, this is your second one. So the right hand side also over, this is your second one. So what we are going to do, we have to take the biconditional between 1 and 2. So for these two, you have to take the biconditional. Biconditional means what happens? So both of them having the same truth value means then only you have true or otherwise false. Look at here, false to false, 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 true false. I think all of them has a value false only because none of the truth value having the identical values like true true. If it is true true means we have true or false false. We doesn't have that pair here, so we get only false alone. Next, one of the important thing you have to notice here that show that the truth values of the following formulas are independent of their components. Very good thing you have to notice. So look at here these following formulas. So P and P conditional, Q conditional, Q1 like that. It's again biconditional statement. Third one conditional, last one involving biconditionals. So if you find out the truth values for all these, look at here. Let me take the first one. So this is your first one we have to take. So after find out the conditional and applying conjunction between and then taking the conditional statement. So on the final value, so here this one I have to mention here, that is the important thing under this topic. So look at the truth values, all are true. So this doesn't coincide with either P or Q, that is statement's truth values. So P has a truth value true, true, false, false, whereas Q has a truth value true, false, true, false. But whereas the result, okay, after applying the conditionals and conjunction after that, finally we get true true. Doesn't coincide with any of the truth values of P and Q. That is the meaning of independent of their components P and Q. So this statement is independent of their components, two components, that is P and Q. That is the only meaning. The second one also. Third one also. So whatever that may be, you have to work out and look at the final values. Definitely that doesn't coincide with the components of P, Q. If it involves three variables means P, Q, R. Okay, that has a distinct truth values, different truth values. Okay, that is the meaning of independent. Okay, that's all. The third one also. So all of them are independent of their components P, Q, and R. Next we have to discuss about connective. So the truth table for P del Q, that is connective. Here P del Q is nothing but true. That is connective. Here it takes the value false only whenever the identical truth value means you have to take the value false. Okay. So it has a truth value false only when both the statements P and Q has the identical truth values false, false, like true, true. Then only it has a truth value false, or otherwise it has a truth value true only. Okay. Next, well-formed formula. So a well-formed formula is generally denoted, that is generated by the following rules. A statement variable alone is a well-formed formula, that is the statement variables like P, Q, R is alone a well-formed formula. If P is a well-formed formula, then negation P is also a well-formed formula. Okay, like if Q is a formula means like that negation Q and Q, these are all well-formed formulas. If P and Q are well-formed formula, then P and Q, P or Q, negation P and negation Q or negation P, the different possibilities between P and Q using the conditional statement here and biconditional statement here are also well-formed formulas. A string of symbols containing the statement, variables, connectives and parentheses is a well-formed formula. So if and only if it can be obtained by finitely many applications of the rules 1, 2 and 3 that we have mentioned as before. For example, negation of P and Q, negation of P or Q, P conditional, Q conditional or P conditional Q and Q conditional or biconditional P conditional or. So here the parenthesis, outer parenthesis very must. Okay. So some cases we may not, no need of using the outer parenthesis. Okay, so that I am going to explain later. Negation P and Q is not a well-formed formula, but negation of P and Q within the parenthesis like this is a well-formed formula, like this one also. That means you are to represent the statement with the parenthesis in a clear format. That is the meaning of well-formed formula. So for our convenience, in some cases we omit the last parenthesis, like we write P and Q for P and Q. So no other operations included between P and Q, but we can use the parenthesis here. This P and Q, conditional Q. For outer parenthesis here not must, but this parenthesis must, isn't it? So that is the meaning of well-formed formulas. Next we move on to tautology. So tautology means in the finally you have the truth, all the possible truth values are true only. That is, a statement formula is true regardless of the truth values of the statement, which is replaced variables in it is called tautology or logical truth. Okay, P or negation P is an example for this. So let me show you our truth table for this one. So P has a two possible truth value, true, false. So negation is nothing but false, true. So if you take or between these two, true or false, true, false or true. So P or negation P is a tautology because the final truth table you have only true alone. That is the meaning of tautology in short. So statement formula is false regardless of the truth values of the statement, which is replace the variables in it is called contradiction. That is opposite to tautology. So there we have only true value, here we have only false. For example, P and negation P, let me show you an example under this case. So for P you have true, false, negation P, false, true. So if you take and between these two, true and false, false, false and true, false. So here P and negation P is a contradiction, which means in the final value, so you get the only false as a result in a truth table. So tautology means it has a truth value true, contradiction means it has a truth value false, right? So the statement formulas A and B are tautologies, then A and B is also a tautology, isn't it? So let me give you a proof of this. So it's given that the statement formulas A and B are tautologies. If I assign any truth values to the variables A and B, then the truth values of both A and B are true, isn't it? So in that case, the truth values of A and B is true, isn't it? So A and B is a tautology, right? Because it is given that the statement formulas A and B are tautologies, which means A and B takes only the truth value true, not the truth value as false. Tautology means it takes only the truth value true alone. So if you take and, that is and between A and B means finally you get the truth value true, isn't it? That's all. Thanks for watching. See you all again in my next video.